Right, hello. Right, this is lesson 12 for the higher paper, and it is called, if I can get this thing, handling data. Okay, all sorts of data, information and things, and it's mainly based around averages. And so there's kind of averages that we'll be looking at are the mean, the range, the mode, and the median. Not in that order, but okay. Right, so first of all, we're going to look at things involving data sets. Data set. Now, a data set is just a row of numbers basically, and so if we have 2, 4, 5, 7, 12, and 15, and 18, yeah, what we're going to do is first of all, we'll look at the range. This is easy, yeah? The range is the difference between the largest and the smallest. So if we look at the data set above us, the largest number we've got is 18, the smallest is 2, and these are all in ascending order. You've got to put things in ascending order first. Not necessarily for this, but definitely for ones that come later on. So the range there is 16. Now the only time when the range could be difficult to calculate, or more difficult, is if you have temperatures, and so therefore you'd have negative numbers. Yeah. And the range is between the biggest, 25, and the smallest, which is -4. So the difference is that -4, minus minus, which is the same as 25 plus 4, which equals 29. The reason being, if I do a little number line there, and down here I've got -4, and up here I've got 25, it's the difference between here. So we have 25 for the top bit to 0, and then we have another 4. This is why we add them together to make 29. The next one that we looked at, or we look at, depending on whether you've done this before or not, is the mode. And the mode is the most common. Now, it's the number that appears the most times. So if we have a data set of 2, 4, 8, 8, 9, 10, 11, and 14, then the number 8 appears the most times, therefore the mode is equal to 8. Now, if I stick another 14 on there, then the new mode would be 8 and 14 because they both appear twice, where the other numbers appear once. Now, if you have 2, 4, 6, 8, 10, you could say that there is no mode because everything appears at the same time. Now, next one is the mean, and the mean is when you add all together, and then you divide by how many there are. Right, let's look at this. Okay, so we've got 2, 4, 6, 8, 10. There's the data set. Add them all together. 6, 12, 20, 30. So you've got 30, and you divide by 5. Therefore, the mean is equal to 6. So that's, you just add them all together. The median. Median is the middle value. Now, middle value. So let's go for 4, 8, 12, 14, 16, 23, and 41. Right, So we need to find the middle. So once again, you need to put these in ascending order, and you need to find the middle. Now it may be easy to see that the middle number is 14, but let's do it this way. N plus 1 divided by 2. This finds the middle position. N is the number of digits that you've got, so 1, 2, 3, 4, 5, 6, 7. So 7 plus 1 divided by 2 is 8 divided by 2, which equals 4. Now this is not the median number, this is the position of the median number. And you go 4 from either end. 1, 2, 3, 4, or 1, 2, 3, 4. You end up with the number 14. So the median is 14. Now, what happens if there is no number in the middle? Let's do this. 4, 8, 12, 14, 16, 23, and 41, and 48. Now this time we're going to use the n plus 1. N plus 1 divided by 2, 3, 4, 5, 6, 7. Now we've got 8 numbers. So this is 8 plus 1 divided by 2, which is 9 divided by 2, which is 4.5. Now, again, this is the position, not the actual number. So we count 4.5 in from either end. 1, 2, 3, 4.5 in there. 1, 2, 3, 4.5. It's in there. It's in between 14 and 16. Now, in this case, it's obvious that it's 15, but if these were all decimals and all sorts of weird numbers, it might be more difficult to find out what is the middle number or the middle value. So in this case, we go back to the way we did the mean. We add the two numbers together. Where's my cursor gone there? 14 plus 16 divided by 2, which is 30 divided by 2, which is equal to 15. So the mean is 15 when you have that particular awkward set. So then let's have a move on to a question about these, and they can get quite tricky. They're quite tricky. So they won't give you just a question like this. That's not GCSE, but this is what you need to know for GCSE. Right. So we've got a data set, and this is for the height of penguins, and it's in centimeters. Yeah. So let's do all the height of the penguins: 41, 43, 44, 44, 47, 48, 50, and 51. Right. Now, to escape, yeah, the mean is now 44.5 centimeters, which to escape. So it's a nice mean, median, mode, that sort of question, but there's a bit of thought involved. Right. So if the mean is now 44.5, after 2 have escaped, there are only 1, 2, 3, 4. There are 6 penguins left. So of the 6 that remain, is 6 times 44.5, which is the mean. 6 times 44.5 is 267 centimeters. Okay, so that is the mean of the remaining 6. Now, all eight penguins, we need to add them all together, and that gives us 368 centimeters. So the difference is the 2 that have escaped, which is 368 minus 267, which equals 101 centimeters. So now we're going to look along there, and they're going to make it easy for you. we need to find two penguins that their combined height is 101 centimeters, which is these two. Yeah, so the 50 and 51 height penguins are the answer. They're the two that have escaped. They're the ones that have escaped. So yeah, there's lots of these type of things where you have a netball team and then two more people join, and you have to find the weight of the two people that join, or something like this. Yeah. So now, next thing is interquartiles. This is what we did, interquartiles. Now, let's have a data set. Let's have a data set and try and work out what this all means. 11, 12, 15, 20, 25, and blame 150. Okay, the first thing to do with interquartiles is to find the median. Yeah, find the median first. Median is the middle value. So we've got n plus 1 over 2. 1, 2, 3, 4, 5, 6, 7 numbers. So that's 8 divided by 2, which equals 4. And that's the position, which is 1, 2, 3, 4, which equals the number 15. Right, ring round the number 15. That's the median. Now, an interquartile is basically because quarter, the whole data is divided up into 4. So the interquartile is actually the median of the bottom half of the numbers and the top half of the numbers. And so we have a lower quartile and an upper. So we have two. So we'll take the lower to start off with. So the lower is the lower quartile is n plus 1 divided by 2. There's 3 numbers in the lower quarter, or the lower half. So that's 4 divided by 2, which equals 2. That's the position. And so count 2 from either end, and we come up with equals 11. The upper quartile, again, n plus 1 over 2. Not the very few numbers, so this is 4 over 2 again, which equals 2, which is the position. And the second one in is 25. Now there is something called an interquartile, Q-U-A-R-T, interquartile range, which is from, this is the lower quartile, this is the upper quartile, and it's like the range for the whole set of data, the smallest and the largest, but this is the range between the two different quartiles. Interquartile range, abbreviated to. We'll come across that again in when we're doing something called a cumulative frequency graph, but for now we're just doing it with the data set. So the interquartile range is 25 for the upper quartile, take away the lower quartile, which is 11, and that gives us 16 as an interquartile range. Now, we moved on from that, and we moved on to frequency tables. Frequency tables. Frequency is just how often something happens, or how often you see it. And we make a table, and we're going to do some. What can we do? What can we do first? Let's say we're going to count the colours of cars. So this is a table, and it is not a very good table, but we will just do a couple of, we won't do too many because it's only just a refresher. So we've got red, blue, black, oh, we'll have another one, yeah, and white. And what we do is we go and stand outside by the side of the road and count the number of cars of these colours. If a green car goes by, ignore it because it doesn't fit in our table. So this, because there is no crossover, there is no sort of, is it red or is it blue? This is called discrete data, and it's data that you count. Okay, discrete data is data that you count. So say we counted 10 red, 8 blue, 6 black, and 1 white. Now, what we can do with this table is we can find the range, the mode, the median, and the mean, all from a table. Right, so the range is the difference between the largest and the smallest in the frequency column. So the range is going to be 10 minus 1 equals 9. The mode is the most common colour, and the most common colour was red because we saw red, 10 red cars. So the mode doesn't equal 10, it equals red. The median. Now we know that the median is the middle value, so first of all we have to count up how many there are. So 10, 18, 24, 25, 25. So you just take this 25, simplistic, it would work 99 times out of 10, divide by 2, which equals 12.5. Yeah? So this is the position of the median. Now, count from the top down until 12.5 would appear in one of these boxes. So you'd go 10, and then you would go 11, 12, 13, 14, 15, 16, 17, 18, and 19, 20, 21, 22, and so on and so forth. Now 12.5 will appear in here. There. And so therefore you look back and see the blue is the median. The median equals the blue. And the range. Now, you know how many there are altogether. And not the range, is it? Hang on. Wait for this to come. It's not the range. Not the range. It's the mean. It's the mean. Now, you've got 25 altogether, and there are 4 categories, so divide that by 4, 12.5, 6.25 or 6 1/4 is the mean. So on average you saw 6 1/4 cars of each colour. Okay, now it can get more complicated, can't it? So we can have this. So one more example of this, of a thing, and we're going to do a survey. Cups of tea. Right. So this time, cups of tea, frequency, and when you do this, 0, 1, 2, 3, 0, 1, 2, 3, 4, that will do. Cups of tea. So 0, 1, 2, 3, 4. The frequency is, we ask people how many cups of tea they drink, and 7 people said they don't drink any cups of tea at all. 8 people said they drink 1, and 10 people drink 2, and 6 people, and 5 people, and so on and so forth. First, whilst you're thinking, you could just add those up together to be 36. Right. So we always have in an exam a column over on the right hand side printed for you with no title. So you think, what's this for? So let's work out the difference. Yeah, so we'll do the range. Now, the range is the difference between the biggest and the largest. Yeah. So it's the cups of tea, not the frequency. The cups of tea is the range. So we've got 5 people drinking 4 cups of tea and 7 people drinking no cups of tea. So we must take into account no cups of tea because there is a positive answer here. If there were no people drinking no cups of tea, then you ignore it and do the range was between 1 and 4. But because people have drunk no cups of tea, you must include the number 0. So the range is 4. The mode is the most common amount of cups of tea drunk. So 10 people said they drank 2 cups of tea, therefore 2 cups is the mode. The median, remember the middle value, so take your 36, divided by 2 is 18, and count down from the top 18. 7, 15, 16, 17, 18, 18 is going to be in here somewhere, so therefore we go left, and we go the median is 2 cups, and the mean, and this is where this extra column comes in. We know we've got 36 people in our survey. We need to find out the total number of cups of tea that they drank, divided by the 36, and we'll have a mean average. So you multiply these two numbers together. 7 times 0 is 0. So this now becomes the total number of cups of tea drunk. 8 times 1 is 8, 10 times 2 is 20, 6 times 3 is 18, and 4 times 5 is 20. And you add those up and you've got 66 cups of tea were drank altogether. So you get the 66 cups divided by the 36 people, and that's more or less 1.83 cups as the mean. Now, this is discrete data. There is no sort of crossover. Nobody drank 1.5 cups or drank a cup and left it to go cold or whatever, or forgot they had one. You either drank 1 or you didn't. You either drank 2 or you didn't. Now there's another kind of table, and this table is called grouped frequency tables. Now, what's this all about? Now, grouped frequency uses continuous data, which is something you measure. As in, how tall are you? How heavy are you? What is the temperature? Something you measure that doesn't go into particular boxes. Say, for example, we were measuring people's height. We might have a column that we start off with good intentions and we go, yeah, 1.6 meters. The next person comes with 1.65, and then we might get 1.63 and 1.632, and this is never ending, and you're always going to have in the frequency column one of each. So this is not the way to display. It won't help you at all. Yeah, imagine you measured the height of 1,000 people, and if you were, depending on the degree of accuracy you were, you might have 1,000 different results because no two people are exactly the same. Therefore, we must group the data together, and grouping the data together means simplistically what we're going to do is we're going to have the small people, the medium people, and the tall people. Yeah, so I can group the height of everybody I measure into 3 lots. So I don't know heights. We can go everybody between 1.4 and 1.6, everybody between 1.6 and 1.8, and everybody between 1.8 and 2. And so we end up with this. Like there. Ooh, bit bonky, bit bonky. I didn't need a line there. I wonder if I can go back, take that line out. Frequency. So we've got the frequency, and this time you will have 2 columns over to the right that we don't know what they're for. Yeah, right. Now we're going to put height in the middle, and we're going to use some symbols, because if someone came in and they were exactly 1.8, we wouldn't know whether to put them in the medium people or the tall people, and the same for the 1.6. Anybody that's less than 1.4 we can forget, yeah, or more than 2 we can forget, because they don't appear in our survey. So we must find a way of using symbols to differentiate between which category they go into. So we use these. We use the height is greater than 1.4 but less or equal to 1.6, and the height is greater than 1.6. So if you are exactly 1.6, we know it goes in the small one. If you are bigger than 1.6, it's going to go in the middle one, as long as you're less than or equal to 1.8. And these symbols are always the same, and they always go the same way. And 99 times out of 100, if not all of them, this will be printed on the exam paper. Now you've got to find the median, mode, range and mean of these. And of course we've got to have some numbers in there, so we'll have the 10, 8 and 6. Yeah, that'd be okay. So let's add up how many people in our survey. 24. We need that information later on. Now let's find the range. Now the range is a difference between the largest and the smallest numbers that we can see in our height columns, providing they've got a positive response in here. If there was a 0 up the top here, we would ignore this row as far as the range is concerned, and we would start with 1.6, but positive responses on all of them. So the range is the difference between 2, which is the largest number we can see, and 1.4. Now I know that you have to be bigger than 1.4 to get into this small category, but you can be 1.41, which is rounded down to 1.4 anyway. So that will be equal to 0.6 meters. I suppose we're doing meters. Yes, we are. Yeah. Now, right now, the mode is the most common that we can see, which is 10 people said they were between this. So the mode is going to be 1.4 H for height 1.6. Not the number 10, but what's it written in there. The other one's a median. Now the median is the middle value, so 24. So we're going to do 24 divided by 2, which equals 12. So count down 12 from the top, 10, 11, 12. It's going to be in here. So the median is now 1.6 H 1.8. Yeah. Now the mean. This is where these extra columns come in. As we did in the previous one, we had one with total. So we're going to have a column called with the total number of height, the total height of these 10 people. Now, we're going to get the word estimate in the question, because we cannot be sure of these 10 people. They're not all the same height, are they? Some could be 1.45, some could be 1.5 or 1.59. And so what we're going to do is we take a midpoint. Take a midpoint, a middle value of this, which this is easy, it's 1.5. But if you had all good numbers, just add the 2 together and divide by 2, as we've done before. So we've got 1.5. Here is 1.7, and here is 1.9. Now, it's in the calculator paper. That's easy, isn't it? That's 15 meters height. So these 10 people together, they are an estimate of 15 meters tall. So I'm just going to use the calculator for these other bits. 8 times 1.7. Just save a bit of brain work. Yeah, 13.6. and 6 times 1.9 is 11.4. So 11.4 plus 13.6 plus 15 equals 40. A nice round number, 40. So that's the total number of the estimated total number of the total height of meters, number of meters for the height. So to find the mean, 40 divided by 24 and divide that by 24 is 1.6 recurring. So the mean height of all these people is 1.6 recurring meters. Yeah, which looks about right because it's somewhere in the middle. Yeah. Right. Okay. So what we're doing now? Group frequency tables. Into quartile range. So now the last little bit we touched on, and we'll do it in much greater detail, is box plots. Box plots, because there's a box in it. It looks like this. Yeah, it looks like that. And this is a pictorial representation of all the information for median, minimum, maximum, and range and quartiles, etc. So let's have a look at some numbers. Yeah, we'll go 2, 5, 7, 8, 9, 12, 15 and 18. Here's a nice set of numbers. Right, let's find the median. Oh, I forgot another number. Let's find the median first. Now the median is the middle. So 1, 2, 3, 4, 5, 6, 7, 8. So 8 plus 1 divided by 2, 9 divided by 2, 4.5, which is the position. And 1, 2, 3, 4.5. In between 8 and 9. There's no need to add these two together and divide by thing. So the median equals 8.5. Now, the minimum is easy. The minimum is 2. The maximum is 18. Now, the lower quartile is these, the middle of that. So we've got n plus 1 divided by 2, which is 5 divided by 2, which equals 2.5, which is the position. And the lower quartile will equal in there 2.5, which is 6. And the upper quartile is these. Remember, don't include the median. Yeah, these. Right, so we've got again n plus 1 divided by 2 equals 5 divided by 2 equals 2.5, which is the position. And in there, in between 12 and 15. Okay, I'm going to do this, yeah? 12 plus 15 divided by 2, which is 27 divided by 2. Half of that is 13.5. Now, the box plot, you're going to get some squared paper to draw this, yeah? And it will give you a grid at the bottom that we will do. So I'm going to go 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, please fit 16, 17 and 18. Okay. Now, the maximum is 18, which is there. We've just put a little line there. The minimum is 2, which is there. The median, what's a median? 8.5. So that goes there. And the lower quartile is 6. And the upper quartile is 13.5, which is there. So you're putting all this information on the grid so that it is the same scale. Now all we do is draw them up together. Remember, this bit in the middle is a big square box. Whoops, it's supposed to fit there, yeah. And so what you can do also is just do minimum, lower quartile, median, upper quartile, and maximum. That's it. So we touched on that. We'll come back to that later in another lesson. So not to worry. And I'll see you in the next one.